This ClickView Enablement module, we will provide you with that next level of troubleshooting when it comes to objects in your ClickView application. In this video, we will show you some unexpected or incorrect object results and how to troubleshoot and resolve them. Let's begin with the first example, where we perform a process of elimination to rule out objects that appear to be functioning correctly and focus on the suspected object or objects. How would you go about troubleshooting this issue? Well, it is often advised to reduce the QVW content to narrow down the issue properly. For example, the bar chart located on the bottom called Number of Movies Over Time has unexpected high bars, and the root cause needs to be evaluated further. As a first step in troubleshooting to narrow down the root cause, it is more efficient to remove all the non-relevant objects from the sheet. To initially avoid losing the application information, it is wise to copy the sheet you plan to troubleshoot. So right-click on the Sheet tab, Dashboard, select Copy Sheet. Also, activate Design Grid from the View menu option to have a clear view of the page objects. Now, delete all objects that are not relevant for the troubleshooting scenario. In this case, we will remove all objects but the bar chart and the list boxes on the left side. If you wish to turn off grid design to make the page easier to look at after, you're welcome to do so. For more complex QVW files, it is recommended to remove as much data as possible inside the application. Go to Settings, Document Properties, Sheets, then highlight sheets 0 through 7. Use Shift or Control. Click Delete, then Apply, and OK to remove these sheets. Reopen the sheet properties to view the list again. With the only remaining sheet highlighted, it is time to validate that there are no other unexpected sheet objects. In this case, there are only 2 objects we need to keep, and delete the remaining line arrow objects. It is generally a good idea to have a current selections object in the sheet during troubleshooting to visualize the selections behind the current charts. Right-click on a blank spot on the sheet. Select New Sheet Objects, then Current Selection Box. We just prepared the sheet. Now we can begin troubleshooting by selecting the highest bar in the chart to limit the data further. Click on the highest bar in the chart. The year 2001 is now selected. By resting the cursor on the bar, it is clear that it represents 84, while the expected known value is 59. To limit the data even further, select the director, Alfonso Cuarón, who appears to be linked to 2 movies. The chart is now limited to 2 movies, which, after double-checking with the translator, appears to be the same title but in 2 different languages. In summary, it is now clear that the chart shows too much data since it counts all releases of the same title instead of the distinct titles. The troubleshooting steps we performed was to reduce the ClickView application to find the issue. So how can we resolve this issue? Let's first take a look at the expression and check to see if it is correctly composed. If we convert the chart into a straight table, we can view the expression results. Press Ctrl, drag and drop the bar chart to get a new copy of the chart. Right-click the new instance of the chart, go to Properties, General, Chart Type, select Straight Table. Click OK and apply the change. To make the analysis easier, focus on 2 years before and 2 years after 2001. Make a selection of 1999 through 2003 in the straight table. Now, go to your data model by pressing Ctrl-T and review the structure. Check to see how the fields in the chart's dimensions and expressions are linked to each other. Investigate the fields in the table Film Count and count the number of movies from both fields, Film ID and Film Count. By adding count expressions into the straight table for both fields, Film Count and Film ID, it is possible to see that Film ID column gives the same result as the original expression. However, the Film Count column has a lower count. So this could be the expression we are looking for. In summary, by exploring two different ways to bring a total count, in this case selecting the Count Film Count, you can see it is the expected lower value, providing a true movie count. Now let's take a look at another method of troubleshooting an object with a different example. In this small example, the pivot table has an unexpected total sum, which does not match the partial sum of the table. The total in the chart should be 26,000 instead of the actual 57,000. The reason for this unexpected total, which may happen from time to time with pivot tables, is that it always represents their totals as expression totals. This means that the expression will be calculated for the entire data set and not only the sum of the results in the table. By switching the chart type from pivot table to straight table, it is easy to see the difference. First, copy the chart and leave the original chart untouched. Then, right-click the copied chart. Go to Properties, General, Chart Type, and select Straight Table. Then, the expression can be copied so that the same expression can be seen both as expression total and as sum of rows. Go to the Expression tab. Right-click the expression and select Copy. Right-click the expressions list and select Paste. Change the parameter Total Mode for the second expression to Sum of Rows. Renaming both expressions can make the evaluation a bit easier. One is expression total, and the new expression is sum of rows. Now the chart has the same value expression in two separate columns with separate total modes. Notice that due to the if construction, the dimension A and B does not show in the chart, since the sum of due of these values are 0. For the second column, value expression total, the expression is evaluated for the entire data set. This means that the if condition in this case is calculated for the entire data. The sum due is calculated for all data and not only for the dimension values displayed in the chart. And if this is greater than 0, the sum of all values will be counted instead of the dimension displayed in the chart. For the value expression total to result in the same total as the value sum of rows, the expression needs to be altered to control the aggregation. In summary, comment out the original expression. By using the AGGR function, called agger function, the expression will be properly calculated over the dimension values. As you can now see, with the new expression, the total will be the same for expression total mode as for sum of rows. Okay, let's take a look at the third example. We will show a scenario where the expression results are a lot greater than expected and different ways QlikView views data. The table in this example shows a number of products and a number of models per product. The product dimension is based on the field product, and the sum is counted over the field model. The expected outcome is to get the number of models per product. By looking at the data model, press Ctrl-T. We can see that the two fields used in the chart product and model are located in separate tables called catalog and warehouse. These tables do not have any common fields. Therefore, the tables do not have an associated connection. Tables that are not connected are referred to as data islands. This situation can easily occur when data is loaded from various data sources without being modified during load to create common key fields to link tables together. In this example, the catalog table could, for example, come from a marketing department data source, while the warehouse data could originate from the warehouse manager's inventory list. As I click on the tab Data Model, I will provide some additional information. QlikView is associative, which means that all fields with the same name are assumed to contain the same type of data. Fields with identical names will therefore become key fields, over which QlikView can evaluate how data is related over the data model. In this case, there is no relation between the fields in the table, so QlikView cannot determine which of the models belong to which product. The way QlikView handles the scenario is to assume all possible combinations of the data in the two data islands, meaning that for a specific product a relationship is assumed for all possible models. As I click on the tab Cartesian Product, I will provide some additional information. If the table is altered to contain both product and model as dimensions, it is visualized that QlikView assumes this combination of all values. This way of combining of all values from two sets of data in order to generate all possible values is called Cartesian product. The behavior as such is not always a problem, but it is sometimes a QlikView application developer must know of so that it can take into consideration during application and data model design. Now, let's take a look at the final example. We updated the warehouse table. If the Cartesian product is not according to expected behavior in the application, the data model probably has to be reworked to get the desired behavior. A way to do this is to associate the data islands so that they become part of the same data structure. For example, the warehouse table has been updated to also include the product ID field so that there is now a link between the two tables. In summary, by adding the product ID to the warehouse table, each model now has a defined product that they belong to, which means that there is a clear connection between the two tables. By looking at the data and the result in the chart, the result adds up much better than before. As a reminder, when you run into unexpected results in relation to chart objects, a great way to troubleshoot these issues is become familiar with your data model along with the data itself, as well as the way you plan to calculate them for a true value. Then start process of elimination to narrow down the issue. A few additional tools and resources you can use include the QlikView Help menu. Also, you can view the Release Notes, Reference Manuals, Article Knowledge Base, and Qlik Community.